Chapter 2.3, the product and quotient rules and higher order derivatives. Day 3. Today we're going to focus on finding the derivative of tangent and cotangent. So let's start with tangent. Now, as you learn in your pre-calculus classes, tangent is the same as y equals the sine of x over cosine x. All trig functions can be boiled down to sine and cosine. And as we're looking for the derivative of this is a division problem. So to take the derivative of tangent, we're going to use the quotient rule. And the quotient rule, y prime equals bottom times the derivative of the top, the derivative of sine is cosine, minus top times the derivative of the bottom, the derivative of cosine is negative sine, all over bottom squared, cosine squared. All right, as we clean the top up, we got cosine times cosine, which is cosine squared, negative sine x times negative sine x, which is positive sine x squared, all over cosine squared. And we can simplify a little bit further. Cosine squared plus sine squared is the Pythagorean identities. That simplifies to 1. So we got y prime equals 1 over cosine squared x. And that is secant squared x. So the derivative of tangent is secant squared x. Using similar methods, we can find the derivative of cotangent. So we will rewrite cotangent as cosine over sine. And again, we'll apply the quotient rule. We will do bottom times the derivative of the top, which is negative sine x, minus top derivative of the bottom, which is cosine x, all over bottom squared. Cleaning up the top, we can see that both terms up top have a negative in them. All right, so we'll factor out our negative. So it'll be negative, and then sine times sine is sine squared. And cosine times cosine is cosine squared. And then sine squared on the bottom. Simplifying further, we see that we have the Pythagorean identity in the numerator. So that's negative 1 over the sine squared of x, which simplifies to negative cosecant squared of x. So the derivative of cotangent is negative cosecant squared of x. Let's compare that to sine and cosine. I want to point out some patterns here. So if y equals sine of x, dy dx equals cosine of x. And if y equals cosine of x, dy dx excuse me, equals negative sine of x. Some things I want to point out. Anything that starts with co, when you take the derivative of it, the derivative of all co's is negative. All right? Derivative of a cotangent is negative. Derivative of a cosine is negative. Anything without the cotangent is positive. Sine is positive. And then compare tangent with cotangent. Okay, notice how tangent leads to secant squared. Cotangent leads to negative cosecant squared. Same thing, sine leads to cosine, and cosine leads to sine. So the tangent and the cotangent kind of have the familiar words in it. So do their derivatives. Sine and cosine, same thing. All right, let's look at some practice problems here. Find the derivative of x cubed sine of x minus 5 cosine x. We need to use the product rule right here because that's a multiplication. So the derivative here will be the first times the derivative of the second. The derivative of sine is cosine, plus second times the derivative of the first, and the derivative of x cubed is 3x squared, minus 5 cosine x. That's a constant multiple rule, so we take the derivative of cosine, which is negative sine, and multiply it by negative 5 to get positive 5 sine x. And that does not simplify, so we leave it. Another example we have is f of x equals cosine x over x sine x. If you wish, you could use the quotient rule on this as well as the product rule because there's definitely division and there's definitely a multiplication in it. However, use some of our trig rules. We got cosine over sine. We can rewrite this as cotangent. And we can divide that by x or multiply by x to the negative 1. I like using product rule more than quotient rule. It's quicker for me. Then we can use product rule on this. So we will go the first function times the derivative of the second, and we just discovered that the derivative of cotangent is negative cosecant squared, plus the second function times the derivative of the first, and the derivative of x to the negative 1 is negative x to the negative 2. We can clean this up a little bit. Pardon me, we'll go negative x to the negative 1 cosecant squared of x minus x to the negative 2 cotangent x. F of x equals cosecant x cotangent x. We have not worked with cosecant yet. So we need to rewrite this one in terms of something we've worked with. And that would be converting cosecant into 1 over sine. So what we got is cotangent of x over the sine of x. And then we can apply our quotient rule. We'll do bottom, derivative of the top, minus top, derivative of the bottom, all over bottom squared. And you can leave it like that. There's probably more you could do, but that is a good equivalent expression for the derivative. And one more. F of x equals sine squared x plus cosine squared x. At first glance, this looks like it could be a little bit difficult. You got your sine with a power on it. You got your cosine with power on it. Rewrite that as sine times sine, apply the product rule. However, if you remember your trig rules from pre-calculus, sine squared plus cosine squared is 1. We've worked with that a little bit previously here. And so f of x equals 1. What's the derivative of 1? Well, that's a constant. The derivative of all constants is 0. All right, f of x equals 1 over cotangent of x. We could use the quotient rule here. Bottom derivative of the top minus top derivative of the bottom. However, it's easier to use our trig rules first. 1 over cotangent is tangent, and we just saw the derivative of tangent is secant squared of x. All right, so in review, in conclusion, we have 4 trig functions we know the derivatives of now. Y equals sine x the derivative is cosine x. Y equals cosine x, the derivative is negative sine of x. For y equals the tangent of x, our derivative is secant squared of x. And for y equals cotangent, our derivative equals negative cosecant squared of x.